Saxon Algebra 1/2, lesson 120. That is the last time you're going to have to listen to me say that, Caleb, because this is the end. Yay, we made it to the end of the book. Well, let me say this. Technically, there are 3 more lessons in this book. It goes through 123. I am stopping at 120 for one very practical reason. The Algebra 1 kids have run out of lessons. Their book maxes out at 120. So I'm keeping all 3 of these classes to the same length. So you're stopping because they don't have any more lessons. There are 3 more lessons in your book. There are topics that we will get to next year. So you're not going to miss out on anything. We're just going to cut you off at the same time so that you're not doing more work than your sister, because I don't think that's fair to you. Of course not. It's not. Okay, so we will wrap up with this lesson. This lesson's another one that we're going to see next year. So it's about volumes. The volume of any shape is equal to the area of its base times its height. Okay, that's the volume of a right solid. Okay, what do I mean by a right solid? I mean an object that has straight sides, like a cereal box, like a coffee can, like a soda can. They have straight sides, right? Like this, it has a straight side. But what if you're dealing with an object that is not a right solid? What if it's got tippy sides? Okay, and I'm not going to take the time to draw them. I'm just going to show you them in the book. Things like this: a triangular pyramid, a rectangular pyramid, a cone, or a sphere. Okay, these are objects that have a familiar looking base, right? This base is a triangle. This one's a rectangle. This one's a circle. That doesn't really have a base. What if you wanted to try to find the volume of those? We have to tweak our formulas, okay? There are formulas. John wants us to memorize how to do them. I don't want to do that. Here are the formulas right here. To find the volume of these 3 objects, what you do is you imagine, okay, what if it did have straight sides? Let's find the volume of that shape. So we find the area of the base, we multiply it by the height, but then we multiply it by 1/3, because essentially what we're saying is that imagine that you have this block and you want to carve out the shape of that pyramid. You would trim away 2/3 of the original block. So if you multiply by 1/3, you'll get what's left. Same for this one, which is based on a square rather than a triangle. If you had a block with the exact same dimensions as the base and the same height, you would have to trim away 2/3 of the block to get to the pyramid that you want underneath. So you multiply the original volume by 1/3 to get the volume of that. Same for this cone thing, which always reminds me of, old-fashioned schools. They used to make kids wear dunce caps if they didn't know the answers, which is cruel and horrible. But I always think a little dunce cap of this, or a traffic cone. Same thing for these. You take the circle that is the base, you imagine a shape with straight sides, and then you carve away 2/3. So 1/3 gives you the shape underneath, okay? Now, this, I always think of tennis balls in tennis cans. Imagine it was, usually you get 3 tennis balls in a can, right? But if you had just a little tiny can, like a Pringles individual serving size kind of, with a ball inside, there you find the measure of that can, but this time instead of carving away 2/3 to get to your shape, you only carve away 1/3 to get to your shape. So if you multiply by 2/3, that gives you the volume of the sphere, okay? So that's the way we approach these. Let's use them. We're gonna do all of this again next year, so don't worry too much about it. What I want you to see is that the calculations aren't hard. If you can just remember the 1/3 and the 2/3. Okay, the base of a triangular pyramid 4 meters tall is shown on the left. Okay, so what John shows us is a picture like this. Oh my Lord, pretend it's straight. This is the base, and John says that. He writes right underneath it, base. Okay, then he draws us the proverbial wedge of cheese picture. Oh, my lines aren't very straight. And then he shows us 6 and 3, and he says right solid. Okay, and then he shows us this. That's a 6, by the way. It looks kind of like a P or a B. Pyramid. Okay, so this is what he's telling us. This is the base of all 3 of these objects, right? This is the base, this is the base, this is the base. Here we have it, let's call this a cheese sculpture. Here we have a wedge of cheese based on this shape, and then we're gonna whittle away some of the cheese so that we just have a pyramid of cheese underneath it. Okay, so this gives us all the information that we know. First, we find the volume of the right solid using the area of the base times the height, and then we'll multiply it by 1/3 to get the pyramid. Does that make sense? So we find the area of the the volume rather, of the right solid by taking the area of the base times the height, and then we use that fraction of 1/3, which is all that's left when we carve away the rest of the cheese to get this pyramid. Okay, so we're gonna I'm gonna write the whole thing out. So it's gonna be the volume of the pyramid is gonna equal 1/3 times the area of the base times the height. Where is the height? It tells us in the words. The base of a triangular pyramid 4 meters tall. Okay, so the height is 4. I'm just gonna write that there. Times 4. Okay, so this is the whole thing. Here's the area of the base. Here's the height. Those two give us the volume of the right solid, and then 1/3 is what we use to get the pyramid. Make sense? So now all we have to do is do the algebra on this. I'm gonna cancel the 3's, and so I'm gonna get 6 times 4. Oh. Wait a minute. Oh, I see what I did. The area of the base is not 6 times 3. The area of the base is 6 times 3 divided by 2, right? Because it's a triangle. Ah, I tricked myself. So 6 times 3 divided by 2 would be 3 times 3, right? I cancel these. I get a 3. 3 times 3 is 9. So that's wrong. It comes down to 9. 6 times 3 divided by 2. I didn't use the proper formula for the area of a triangle. I needed to divide by 2. Okay, so now I have 1/3 times 9, which is the area of the base, right? I'll do it again over here so you can see it. The area of the base is 9. The height is 4. So it's 9 times 4 divided by 3. I'm going to cancel those. And so it's 12. What's our unit? Meters. cubed because it's the volume. The volume of the pyramid. That's a way you can write that as volume, and then you use the P as a little subscript. Okay? Sorry, I made that more confusing than it needed to be. Let's do another one. There are, no. John, just no. Sorry, I'm ranting. Example 120.2. Find the volume of a circular cone 4 feet tall. Okay, so again, it says find the volume of a circular cone 4 feet tall. So the height equals 4, whose radius is 10 centimeters. So this is the way our shape looks. Pretend it's perfect. That's two. Mine looks like a dog bowl. It's supposed to look like, say, a coin or a perfectly flat tablet. So this is the base. This is the right solid. But we are going to take that tablet or cone and we're going to carve it into a cone shape. So it's sort of like that. Okay? And this is the cone. It's kind of a flat cone. There. Looks a little better. The pictures in the book are more perfect if you want to look at those. Okay, so we know to find the volume of the cone, we want to take the 1/3 magic fraction and we want to multiply that by the area of the base. And we want to multiply that by the height. Okay? Here's the base. What's the formula for the area of a circle? Oh, it's pi r squared, right? So it's going to be 3.14 times 10 squared. Okay, 10 squared, that has 2 decimal places, so we can just bounce this 1, 2. It's going to be 314, right? So the area of the base is 314, and we're going to multiply that by the height, which the problem told us was 4. Okay, and then we can, dividing it by 3 is not going to come easily. So let's just do 314 times 4, 6, 5, 1, 2, 5, 6. So it's the volume of the cone equals 1,256 divided by 3. Okay, I'm liking that. That looks good. And then let's see if we can just divide that. 1,256 divided by 3. It goes in there 4 times, 12. Subtract and bring down the 5. There's 1. Subtract the 3. 26. Well, shoot. It's not going to be 9. It's going to be 8. 24. We have 2 left, and we're just going to call it 2/3. We're going to just leave our answer as a fraction. So the volume of the cone equals 418 and 2/3, whatever our unit is. I look back at the problem, and I see that it is centimeters. Centimeters cubed. This would also have been a perfectly fine answer. If we were on a test and you gave me this as your answer, I might just ask you to divide it, but I wouldn't take any points away for you leaving it in that form. That's perfectly fine. Okay. Needed another piece of paper to do the last one. Lesson 120. Oh, I didn't need to write that again. Oh, well, that's okay. Example 120.3. This time we have a sphere. These are kind of fun to draw. Try to make it look a little dimensional. And then we show that here in the middle, we have a radius of 10. Okay, so the volume of a sphere equals 2/3. We use the different fraction on this one because more of the original shape is left, right? We imagine it in a can, right? And I can kind of draw that. Right, we're imagining that it's in a can, perfectly sized, right? So this is sitting in the middle of the bottom, and the top of the sphere is touching at the middle of the top, right? It's perfectly custom fit in there. The radius is 20. Okay, so we want to do the area of the base times the height. Okay. What? We only have one number. Well, here's the fun thing. We get to figure all this out. The area of the base is down here. We need to know the radius of the base, right? This is the base of this circle-y that we built around it. Well, then this also has a radius of 10, right? So the area of the base is going to be pi r squared, or 3.14 times 100. 10 squared is 100. John's giving us these nice numbers to get rid of the decimals and make our life better. So the area of the base is 314. The height, how are we going to figure out the height of this shape? John does not tell us the height. Well, he does, but he doesn't tell us directly. Here's the way we figure it out. If this, see how we have this right solid around the can? If the center of it is the center of the sphere, right about here, I'm drawing like a mental line out here, then we have one length of the radius that goes up and one length of the radius that goes down. Each radius is worth 10. So that means the height equals 20. We have to deduce that by using the radius and the fact that the radius is going to go equally up and down. That's hard. Excuse me, I'm yawning. That's hard. That's a tricky thing to figure out. But that's how we figure out that the height of the object is 20. Okay, ready? So now to put all this together, we're going to say, I'll do it down here. The volume of the sphere equals 2/3, because that's the magic sculpting fraction, times the area of the base, 314, times the height, 20. Okay? That's kind of a lot, isn't it? We need to simplify this. Again, if you gave me this much of an answer on the test, I'm not going to test you on this. Let me just say that. But if I was, and you gave me this much of the answer with a unit on it, I'd be pretty happy. But let me just show you the volume of the sphere equals, if you multiplied these together, you would get, let's see, this would double, so it would be 628 and a 0. And then we'd multiply that by 2 and divide by 3, and the final answer would be 4186.67. So obviously that would repeat, centimeters cubed. Either of those would make me happy for an answer, okay? So this is perfectly fine. Tricky, right? These are tricky. Now, I'm going to show you something that I don't like. That is only part A of this lesson. John goes on to part B, and he talks about how to calculate the surface area of pyramids and cones. Okay? So this time, instead of finding the volume of it, we're imagining, well, what if it was made out of paper and we opened it up and found the area of that paper? I call foul. This is too much information in a single lesson, especially the last lesson of the year. This is too much. We're not going to do the surface areas. I just want you to know that there is a process, because it's complicated too. It introduces a whole new concept. We are not going to go here. Okay, so surface area of pyramids and cones, I'm saving for next year. We'll get to it. I don't expect you to know about that ahead of time. So we're just going to talk about the volumes. Here are all the formulas. Those are the examples we just walked through. This will not be tested. I will not test you on this, but I do want you to slog through the homework because next year when we come back to it, you'll be in good shape. All right, Caleb, guess what? I'm officially done teaching you new lessons of Algebra 1/2. Do your homework, take the test, and you will be done, completely done and ready for summer. And then in the fall, we'll just start all over again. That'll be great. No, but really it will be fun. So I like Algebra 1, the text and the way the lessons work. I like Algebra 1 better than 1/2, and I like Algebra 2 better than Algebra 1. So it's just gonna keep getting better. I mean, as if this isn't great enough. Come on, but it's only gonna get better. So, all right, good luck with your homework. I will be talking to you before the final. Good luck, goodbye.